So hello everyone. So welcome to this session. So in this session we are going to start a new chapter of +1 chemistry, that is redox reactions. So as the name suggests, redox reactions are nothing but reactions in which both reduction and oxidation occurs simultaneously. So those reactions are termed as redox reactions. So in this chapter we will study what do you mean by reduction, what do you mean by oxidation, and then we can also learn by seeing a reaction how can we tell whether the reaction is undergoing reduction or oxidation. So these are the basic things we are going to learn from this chapter. Once we cover the basics, we will move to some application part. That one we will study as we move on. Okay, so first, as I told you earlier, we will define what is oxidation and what is reduction. Okay, defining oxidation and reduction by classical concept. Classical concept means old concept. So in olden days, old chemistry, how they defined oxidation and reduction. Once we complete this, we will define oxidation and reduction by using modern concept. Okay, so modern concept means present chemistry, how the present chemistry deals with the definition of oxidation and reduction. So first we'll start with classical concept of oxidation and reduction. So oxidation means addition of oxygen or removal of hydrogen or addition of electronegative elements or removal of electropositive element. Okay, so I think in lower classes you might have studied addition of oxygen or removal of hydrogen as oxidation, but in this discussion we will extend our definition to this, that is addition of electronegative elements or removal of electronegative elements are also termed as oxidation. Okay, so for each of the definition we will justify the definition by taking some example. So addition of oxygen, I will move on to next slide. So once again I will write a definition of oxidation. Oxidation is nothing but addition of oxygen or removal of hydrogen or addition of electronegative element or removal of electropositive element. We will justify these definitions by taking some example. First let us consider addition of oxygen. Take an example, magnesium treated with oxygen to give magnesium oxide. So I will balance this equation, and remember we will learn balancing a chemical equation in the next part. Okay, so in this case oxygen is added to the magnesium to give magnesium oxide. So this is an example of oxidation reaction. So in this case we can say magnesium is undergoing oxidation. Magnesium is undergoing oxidation. Okay, so let us justify the second definition of oxidation, removal of hydrogen. So that is, take a familiar molecule, that is methane. You people are aware with this. Treated with oxygen, it will give carbon dioxide with water. So in this case you observe methane molecule getting converted into carbon dioxide. Here the hydrogen has been removed from the compound, isn't it? So this is nothing but oxidation. Okay, so addition of oxygen or removal of hydrogen from a molecule is oxidation. So here methane is undergoing oxidation. Okay, then next is addition of electronegative element. This is also termed as oxidation. So take an example, magnesium plus fluorine giving magnesium fluoride, MgF2. In this reaction, which is the electronegative element? That is fluorine. So electronegative element is added to magnesium, so that this reaction is an example of oxidation reaction. So in this case, magnesium is undergoing oxidation. Okay. So first of all, I want to give a simple introduction about what do you mean by electronegative element and electropositive element. So before that, let me complete this whole definition. So take this definition and justify the definition. Okay, removal of electropositive element is also termed as oxidation. So example, potassium iodide plus hydrogen peroxide giving iodine plus 2 moles of potassium hydroxide. So in this case, which is the electropositive element? Potassium. Potassium is electropositive element, that is exists as K plus. So this potassium is has been removed. Okay. So this is an example of oxidation reaction. So first, let me tell you what do you mean by electronegative elements and what is an electropositive element. Actually, this not belongs to redox reaction concept, but a brief introduction. So electronegative elements are nothing but in a periodic table the elements which lie towards right side of the periodic table. So generally they are p block elements or electronegative elements like chloride, bromide, iodide, fluoride. These are all electronegative elements and they show negative oxidation state or oxidation number on their atom. Then electropositive elements are nothing but generally they lie towards the left side of the periodic table. Generally S block elements or D block elements are also electropositive elements like sodium exists as Na plus, potassium ion K plus, lithium Li plus, calcium 2 plus. These are all electropositive elements. So if any electropositive elements is getting removed in a reaction, then that reaction is undergoing oxidation. If any electropositive elements are getting removed in any reaction, means that is oxidation reaction. If any electronegative element is getting added, if any electronegative element is getting added to the molecule or an atom, then such reactions are nothing but oxidation reaction. So for every definition we have justified our definition by taking one example. The next we will study reduction. So reduction nothing but addition of hydrogen or removal of oxygen or addition of electropositive elements or removal of electronegative elements. So this is nothing but reduction. So once again we will justify our definition by taking one examples. Okay. So reduction we are discussing now. Reduction means addition of hydrogen or removal of oxygen or addition of electropositive element or removal of electronegative element. So addition of hydrogen, just a simple example like bromine is treated with hydrogen sulfide, that is H2S. This will yield hydrogen bromide plus sulfur. So in this case, concentrate on this reactant bromine and hydrogen bromide. In this case, to this bromine molecule, hydrogen is being added, isn't it? Hydrogen is being added. So this is an example of reduction reaction. Then once again, for oxygen, removal of this for hydrogen. Now we will discuss for oxygen. Okay, simple. Mercuric oxide, that is HgO. When you heat this, you will get mercury plus oxygen. So in this case, mercuric oxide is getting reduced to mercury because oxygen is being removed. and we know that removal of oxygen is nothing but reduction. Next, electropositive elements. So if electropositive elements are added to the atom, then such reactions are also known as reduction reactions. Okay, so take a simple example. CuCl2 plus copper giving Cu2Cl2. So in this case, copper is electropositive element. You know that copper exists as Cu plus and Cu2 plus. Generally copper is an electropositive element. Okay, so what is the name of this Cu plus? Generally this is known as cuprous. This Cu2 plus ion is known as cupric. Okay, so here copper is getting added to this molecule, isn't it? You observe these two. Here one Cu was there, here another copper being added. So since here electropositive element is getting added, then such reactions are nothing but reductions, and we will say this molecule is undergoing reduction. And electronegative elements, last example, take a very simple example. FeCl2 plus hydrogen giving FeCl3 plus hydrogen giving FeCl2 plus 2 molecules of HCl. So in this case, chlorine is electronegative elements because Cl exists as Cl minus. In this case, you observe these two molecules. One chlorine molecule has been removed. So removal of electronegative elements is nothing but reduction. So this reaction is nothing but reduction reaction, and this molecule is undergoing reduction. So this is how oxidation and reduction can be defined. Okay, then what do we mean by redox reactions? Very simple. If in any reaction oxidation and reduction occur simultaneously in a single reaction, then such reactions are known as redox reactions. Okay, so very simple example. Remember this simple example, that is hydrogen sulfide H2S. Hydrogen sulfide combines with chlorine molecule to give hydrochloric acid plus sulfur. Okay, in this case hydrogen sulfide is getting oxidized to sulfur, undergoing oxidation, and chlorine molecule is getting reduced to hydrogen chloride. So chlorine is undergoing reduction. So since both oxidation and reduction are taking place in a single reaction, this reaction is known as redox reactions. But this is an activity for you. After the class, you study this, how H2S is undergoing oxidation. How can we define oxidation in this case? How can we define reduction in this case? So for that, the basics which we have provided, that is enough for you, I think. So you can do this after your class. The next is modern concept of oxidation and reduction. So modern concept means, so present day chemistry defines oxidation and reduction in different manner. Okay, they will not define oxidation means addition of oxygen or removal of hydrogen. Reduction means removal of oxygen or addition of hydrogen. They will not define like that. Modern concept, modern chemistry will define in a different manner. That too in electron transport concept, that through oxidation number concept. Okay, for these two concepts we need some basics about oxidation number. So first we will learn oxidation number concept or oxidation state concept, then we will come back to this concept and we will study electron transfer concept and oxidation number concept. So first we will study concept of oxidation number. See, this is simple, you can learn easily. Oxidation number. So oxidation number is nothing but oxidation state of an element in a compound. What is oxidation state? I think you people familiar with H plus, Cl minus, Br minus, F minus, Na plus. This is Ca2 plus calcium ion and Mg2 plus magnesium ion, Ba2 plus barium ion, isn't it? So these are all nothing but oxidation states. The charges on the apex of the atom are nothing but oxidation state. So these oxidation states are nothing but oxidation number. Okay. So oxidation number and oxidation state both are the same, one and the same. Okay. So now how they assigned the oxidation number. Okay, how they assigned oxidation number, so that one we will study, those rules we will study. Okay, these rules are not important for your examination point of view, but this is necessary to understand the basics. Okay, how we assign, how we give oxidation number to the element. Okay, standard forms. So one by one we will discuss this. First, oxidation number of an element in its elementary form is 0. Okay, so oxidation number of any element in its elementary form. Elementary form means free state, free from, free form. Free form means whatever the elements you see in the periodic table are nothing but free elements like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. So these are all elementary forms of elements. So these elements in their elementary form will possess oxidation state 0. So oxidation state of any element in its free state or in its elementary state is 0. That is the first rule. Okay. Then let me move on to second one. In a single monoatomic ion, the oxidation number of atom is same as the charge on the ion. Okay, see in a single monoatomic ion. So single monoatomic ion like monoatomic ion H plus, monoatomic ion Cl minus, Br minus, I minus, or sodium Na plus. These are all single monoatomic ions. So in this case, they are telling oxidation number of atom is nothing but the charge of the atom. Okay, so here H possesses plus 1 charge, so oxidation number of hydrogen is plus 1. Here chlorine possesses minus 1 charge, so oxidation number of chlorine is minus 1. Here bromine possesses minus 1 charge, so oxidation number also minus 1. Sodium possesses plus 1 charge, so oxidation number is plus 1. Okay, in this case magnesium 2 plus. Here magnesium possesses oxidation state plus 2. So charge plus 2, so oxidation state will be plus 2. So this is how the second rule states. Okay, then third one is oxidation number of hydrogen is normally 1. Okay, so oxidation state of hydrogen is normally 1. That's the reason why hydrogen exists as H plus. But in case of metal hydrides, the oxidation state of hydrogen is minus 1. Okay, this one you have to remember. This is the exception of hydrogen. Exception. That means, what do you mean by metal hydrides? Metal hydrides means metal in combination with hydrogen. So for example, lithium hydride LiH is a metal hydride because lithium is a metal and this is an hydrogen. So combination of metal and hydrogen is nothing but metal hydride. So lithium hydride is metal hydride. So in this case, since lithium is highly electropositive in nature and it is an S block element, so lithium will possess plus 1 charge. So since in order to neutralize the plus 1 charge, hydrogen has to possess minus 1 charge. So that molecule, the overall molecule can become neutral, that is 0, so that molecule can become stable. So since lithium is getting plus 1 charge on its apex, hydrogen must possess minus 1 charge. So the charge of the hydrogen in lithium hydride is minus 1. So here the hydrogen possesses negative oxidation state, that is minus 1. So Generally hydrogen possesses plus 1 oxidation state, but in case of metal hydrides that will possess minus 1 charge. Okay, that is the third point. So the next is oxidation number of oxygen is normally 2. Okay, for oxygen normally 2. That is the reason single oxygen will possess 2 minus charge, but that will exhibit minus 1, plus 1 and plus 2 in some cases. Okay, so for example, take a very simple example, sodium peroxide, that is Na2O2, sodium peroxide. So in this case, sodium is highly electropositive element. So one sodium atom will possess, we are familiar, that is Na exists as Na plus. One sodium atom will possess plus 1 charge. So there are two sodium atoms. So Na2 will possess plus 2 charge. In order to neutralize this, oxygen, two oxygen molecules must possess minus 2 charge, so that whole molecule can become 0. So here two oxygen molecules are possessing minus 2 charge, one oxygen molecule possess minus 1 charge. So this is how here oxygen is getting or exhibiting minus 1 oxidation state. Okay, but normally the oxidation state of oxygen is minus 2, but in case of in some compounds that will exhibit minus 1 as well. So next is, take another example, that is oxygen difluoride, OF2, oxygen difluoride. As we know that fluorine is electronegative element, fluorine exists as F minus. So one fluorine atom will exist minus 1 oxidation state. In this case we have two fluorine atoms, so it will exhibit minus 2 oxidation state. In order to neutralize that, oxygen must possess plus 2 oxidation state, so that overall molecule can become 0 charge, isn't it? So in this case, oxygen is showing plus 2 oxidation state. Take another example, that is dioxygen difluoride molecule, O2F2, dioxygen difluoride. Two fluorine molecules will show minus 2 oxidation state. In order to neutralize this minus 2, oxygen must possess plus 2 oxidation state, so that overall molecule can show 0 oxidation state, neutral molecule, isn't it? Because stable. So in this case, two oxygen molecules showing plus 2 oxidation state, but one oxygen molecule will show plus 1 oxidation state. So in this way, oxidation number of oxygen is normally minus 2, but in some cases that will show plus 1, minus 1 and plus 2 oxidation state. This is about fourth point. Then next, that is in compounds having metal and non-metal, metal possess positive oxidation number, non-metal will possess negative oxidation number. See, for example, simple example we can say, that is magnesium chloride, MgCl2. So generally magnesium belongs to S block elements, chlorine belongs to P block elements. So generally S block elements are metals in metallic in nature, P block elements are non-metallic in nature. So they are telling that non-metals will generally possess negative oxidation state. Yes, always chlorine exhibits as Cl minus, isn't it? So in this case, 2 chlorine will provide minus 2 charge. In order to neutralize this, magnesium will possess plus 2 charge. Yes, metals generally possess what? Positive oxidation state. That is the reason metals exhibits positive charge, non-metals exhibit negative charge. So that is how we can justify. And last thing is, in neutral molecules, the sum of the oxidation numbers of all the element is 0. Yes. Take any molecule in the sense very simple, that is magnesium chloride you take. Okay, so sum of the oxidation states of all the metals will be equal to 0. See, what is the oxidation state of magnesium? Plus 2. Chlorine minus 2 is equal to 0. You take any molecule like hydrochloric acid, hydrogen exhibits plus 1 oxidation state, chlorine exhibits minus 1 oxidation states, so sum will be equal to 0. You take which one? Sodium chloride, familiar simple example, NaCl. So sodium exhibits plus 1, chlorine exhibits -1, sum of the oxidation states of elements will be equal to 0. You take sulfuric acid H2SO4, hydrogen exists as H plus, 2 hydrogens, therefore plus 2. Sulfate exhibits as SO4 2 minus 2. So sum of the oxidation states will be equal to 0. So this is how all the rules of oxidation numbers can be well understood. Okay. So now we will work out some examples. Okay. I will tell you how to work out those. So examples. So how can we work out? Actually they will ask calculate oxidation numbers of following elements. Okay. So first we will work out some examples. Calculate the oxidation number of carbon in methane molecule. Okay. So what is the oxidation number of carbon? So first we will write the molecule CH4. So we have to calculate the oxidation number of carbon. So I will take oxidation number of carbon as X, and hydrogen exhibits +1 oxidation state, isn't it? So there are 4 hydrogen atoms, so 4 into +1. So and we know that from the rules, sum of the oxidation number of the elements will be equal to 0, and solve this. X plus 4 into 1 is 4, that is equal to 0. X is equal to -4. Therefore oxidation state of carbon is -4. That is how we can calculate the oxidation number. And take second example, simple example. So in potassium permanganate, KMnO4, potassium permanganate, second example, calculate the oxidation number of manganese. So first write down the molecule KMnO4. So I have to calculate the oxidation number of manganese. I will take this one as X, and as you know that potassium exhibit +1 oxidation state and oxygen exhibits -2 oxidation state, but there are 4 oxygen atoms, so 4 into -2. So and I know that sum of the oxidation states of all the elements will be equal to 0. Solve this equation, you will get the oxidation state of manganese. 4 into 2, 8, -8 is equal to 0, and X is equal to +7. So in this case manganese exhibits +7 states. Manganese exhibits +7 state. And solve another example. Potassium dichromate, K2Cr2O7. In this case calculate the oxidation state of chromium. So I will take oxidation state of chromium as X. Since there are 2 chromium atoms, I will put 2x. Potassium exhibits +1 oxidation state. Since there are 2 potassium, 2. Okay, then oxygen exhibits -2 oxidation state. Since there are 7 oxygen atoms, so I will multiply with 7. Now sum of the oxidation states of all the elements will be equal to 0. So that is 2 plus 2x minus 14 will be equal to 0. Then 2x will be equal to how much? 12. X is equal to +6. So chromium, single chromium exhibits +6 oxidation state. So this is how we can calculate oxidation state of the elements. I hope you understood this, isn't it? The next is homework. You calculate oxidation number of the underlined ones. Okay. So you take down phosphoric acid H3PO4. Calculate the oxidation state of phosphorus. Second example, you can take iron oxide, that is Fe2O3. In this case calculate the oxidation state of iron. And another example, you can take sulfuric acid H2SO4. In this case calculate the oxidation state of sulfur. So you do this as homework, and by the next session we will start with modern concept of oxidation and reduction. So we'll start from here in the next class. Okay.